And then, of course, yeah. This is slowed down a little. So. But that first launch did take a while to get off the pad. I was very worried there for a second. I mean, when that took off, I was like, wow, I can't believe it took off. That was my reaction. So I think it's incredible that we took off twice last year. I mean, even though I've been very closely involved with the Starship program from the beginning, and actually, like, I lived out here. This is my primary residence for 3 years. This used to be a sandbar, basically, what we're looking at here. And now it's got an advanced rocket factory and a gigantic launch pad, and we've got a whole bunch of rockets out there. But I'm still amazed that it actually got put together and it took off. I'm like, wow. I mean, the Starship is more than twice the thrust of a Saturn V. It is by far the biggest flying object ever made. And with some upgrades down the road, it'll actually be, I think, probably over 20 million pounds of thrust. And Saturn V is 7.5. So it'll end up being 3 times the thrust of Saturn V. And it's going to fly a lot. It has to fly a lot. So it's going to end up flying several times a day from many different locations in the world. And I think there's a pretty good chance that it does Earth-to-Earth transport as well. Because the fastest way to get from one place to another on Earth is, to get from here to the other side of Earth is an intercontinental ballistic missile. But just make sure you delete the nuke and add the landing part. Basically, that's the fastest way to get somewhere. Yeah, wow. And then between Flight 1 and 2, we made a number of massive upgrades. So there was obviously a massive upgrade to the launch pad. So we've got like our mini Niagara Falls here. I mean, the water pressure is so much that if it went straight up, it would actually destroy the rocket. That's how much water pressure it is. So it's like, wow. And it worked. Actually, went and looked at one of the first things I went and looked at after the second launch was to check out the launch pad, because obviously after the first launch we dug a pretty big hole, and honestly it looked like it looked like there was no damage at all. Like you could just launch again basically for the pad itself. So it's great work by the team to radically improve the launch pad overnight. Yeah. The people always want to use the Statue of Liberty for stuff. Statue of Liberty is not that big. I was been there. I actually climbed up the Statue of Liberty in the tiny staircase a long time ago. But anyway, this is a big rocket, and it will get bigger over time. So, yeah. So that's, I don't know if you guys watched Kong versus Godzilla. It's like one of the most insane movies I've ever seen, but it's like kind of entertaining in its sheer madness. The crazy thing is that our launch tower is bigger than Mechazilla. And it's going to do basically like the same thing, but with the arms, like catch the rocket. And when I tell people, like, yeah, we're going to catch the largest flying object ever with giant mechanical arms, they're like, there's no way that's real. I mean, we could give it legs, too. just give it legs and have it tromp around. That'd be pretty cool. And then we're also going to build a second tower. Yeah. So we're going to really be launching a lot, and we're going to be upgrading one tower while we launch from another tower. So 2 towers is important. And there are actually so many upgrades between Flight 1 and 2 that it would actually take like hours to go through them all. But one of the biggest upgrades was going from hydraulic to electric actuation of the engines. So that actually saved a lot of mass and complexity. The electric TVC, I mean, it was just, this is one of the biggest upgrades. We also massively upgraded the heat shield. The engines themselves were massively upgraded. Literally everything on the rocket was, there might have been thousands of upgrades between Flight 1 and 2. So really gigantic improvement between Flight 1 and 2, and also obviously many improvements between Flight 2 and 3. And then we've got a whole development plan to, like I said, ultimately get to a fully reusable rocket that does over 200 tons to orbit on a regular basis. Full reusability. Yeah. Hot staging. I mean, hot staging was a change that was basically, I don't know, just really within a space of like 3 or 4 months, maybe less, going from, or roughly that, going from previously just kind of like separating the rocket without anything, and to actually lighting the upper stage engines while the first stage engines are still thrusting, and not blowing up the ship, that was an amazing achievement. So I was like, wow, and it worked. So I was like, wow. So then let's look at Flight 2.
Attention all operators on countdown 1. This is the final go, no go for Flight 2 of Starship. Gain RT0 is at 7 a.m. Central. Raptor 1.
Go.
Raptor 2.
Go.
Stage 1.
Go.
Stage 2.
Go.
Copy, go for flight. Clock is rolling. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Boost ratchet cut off. Stage separation.
So, yeah, big round of applause, guys. Wow. So flight 2 actually almost made it to orbit. In fact, ironically, if it had had a payload, it would have made it to orbit. Because the reason that it actually didn't quite make it to orbit was we vented the liquid oxygen, and the liquid oxygen ultimately led to fire and an explosion, because we wanted to vent the liquid oxygen because we normally wouldn't have that liquid oxygen if we had a payload. So ironically, if it had a payload, it would have reached orbit. And so I think we've got a really good shot of reaching orbit with Flight 3, and then a rapid cadence to achieve full and rapid reusability. And I mean, kind of the mind-blowing thing is, like, there is an actual path that we are on to make life multiplanetary. Can you friggin' believe that? Like, what? Yeah, we just got to get it done before civilization ends. But like, I think it's going to happen. Yeah, right here. So anyway, so in terms of getting there, we obviously want to accelerate the production and testing, get to a high cadence. For any given technology development, there it is. How many iterations do you have, and what is the amount of time between each iteration? So every time we launch, or do a test, we learn something more. So increasing that cadence of launching and testing, and it's always better to sacrifice hardware rather than sacrifice time. Like, time is the one true currency. So it's sort of the fastest path to, as I was saying earlier, rapidly reusable, reliable rocket. Yeah. So, and we've got a block, sort of a version 2 ship that will be more reliable, better performance, endurance. We've got a version 3 ship design that will stretch, that be even taller, probably end up being, I don't know, 140 meters before it's all said and done, maybe 150 in the end, in length. Yeah. So it'll be even taller than it currently is. Yeah, and so with flight 1, the goal was not to blow the pad up and ideally get some distance, which we did. With Flight 2, it was to get past staging, so we achieved the goal of getting past staging and almost to orbit. And then Flight 3, we've got, we want to get to orbit, and we want to do an in-space engine burn from the header tank and prove that we can reliably deorbit. We want to do a tipping point header domain propellant transfer. This is important for the NASA Artemis program. And we want to also demonstrate the payload door for the sort of PEZ dispenser for delivering the Starlink, the V2 non-mini, actually probably V3 technically, but the really giant satellites to orbit. Yeah. So, like I said, the mass orbit ultimately of Starship will be, over time, I think millions of tons of payload to orbit. So, compared to present day mass to orbit, it'll be more than 1,000 times. More than 1,000 times greater than mass to orbit currently. That's what it will be eventually, or it needs to be. So we also want to demonstrate on-orbit refilling. This is very important for the NASA Artemis program. So we're very proud to be part of the NASA Artemis program. I'm always incredibly grateful to NASA for their support and for trusting us to take astronauts to orbit, to take cargo to the space station, and to be an integral part of getting astronauts back to the moon. One of the other questions I get a lot is, did we really go to the moon? I've gotten that from a lot of people. And I'm like, yes, we went to the moon. More than once, in fact. But the crazy thing is that it's been over half a century since we last went to the moon. So, I think maybe that's what causes people to be skeptical. Like, how come we can't go to the moon now? It was 66 years from the first controlled powered flight of the Wright brothers in 1903 to landing on the moon in 69. So only 66 years. But, like 50 years have passed since we last went to the moon. But now we're going to go back there, and we're going to go back there soon. And we're not going to just. I think the next step, I think, is to build a moon base, like Moon Base Alpha. Make sci-fi real. Remove the fire part of sci-fi. So, but in order to go and land on the moon, one of the technical challenges we have to solve is orbital refilling, where the starships dock on orbit and transfer propellant. Now, we've gotten very good at docking because we dock with Dragon to the space station, which is actually more complicated than docking with our own spacecraft. So we have a lot of expertise in docking, so I'm confident we will solve this, and we just ideally want to solve it hopefully by the end of this year, but certainly by next year. And that's a big deal. This is one of the fundamental technologies that's necessary to build a city on Mars and to have a moon base. And then, we'll also be launching some very big satellites. World's biggest Pez dispenser. And we do hope to do this by the end of this year. And then, more about the NASA Human Landing System. So, as I said, we're extremely grateful to NASA for entrusting us with a fundamental part of the Artemis program. We want to make sure we do a great job for NASA. And really, we are a very fundamental part of the Artemis program. So if we do not succeed, which we will, but in order for the Artemis program to succeed, we must succeed with Starship. Like I said, we actually want to far exceed what NASA has asked us to do. So we want to go far beyond the NASA requirements and actually be able to put enough payload on the moon with enough frequency that you could actually have a permanently occupied moon base. That's the next really big threshold from Apollo, is have an actual moon base. I remember seeing this, I guess, kind of cheesy sci-fi show a long time ago called Moon Base Alpha. I don't know if anybody's seen that, but the moon actually drifts away from Earth. Now, this is not going to happen, but it was a cool show, Moon Base Alpha. But we need a real Moon Base Alpha, and we're going to do it. So then, as I was saying, this is the long-term goal. This is what we want Mars to look like, is starships coming and going, an incredible, beautiful Mars city, and a flourishing civilization on Mars. Ultimately, we can transform Mars into an Earth-like planet with terraforming. Just needs to be warmed up, really, and then it could be ultimately an Earth-like planet, and we could bring the life from Earth. We could extend life from Earth to Mars, and really, it has to be humans, because it's not going to be the dolphins. But we can bring all the creatures with us, and we can ensure that life on Earth continues on Mars, even after Earth becomes unlivable in the distant future. So anyway, I'll go into questions.